Hello, everyone. Today we will cover simple harmonic motion. Simple harmonic motion is motion that is repeated due to conservation of energy. For example, think of a frictionless pendulum. It will constantly change velocity, but the pattern will be repeating endlessly. So, why is this? This is because the potential energy is converted into kinetic energy, and then it'll convert back to potential energy because the motion of the kinetic energy will cause it to gain height, which will gain gravitational potential energy, and the cycle repeats itself. So, in order for something to be a simple harmonic motion, it needs to be a frictionless system so that the energy can endlessly convert back and forth without losing energy. The two systems we'll explore is the simple pendulum and the simple oscillating spring. A simple harmonic pendulum is a pendulum system that does not have any friction. It operates by having gravitational potential energy convert into kinetic energy, giving a velocity. Then, from that velocity, the pendulum gains height, which converts the kinetic energy back into the potential energy. The period, or how long it takes to complete a full cycle, is given by 2 pi multiplied by the square root of the length, given by this L, divided by the acceleration due to gravity. The frequency, or how many cycles are completed in 1 second, is the inverse of the period. So it is given by 1 over 2 pi multiplied by the square root of acceleration due to gravity divided by the length of the pendulum. The next simple harmonic system is springs. They use the spring force given by Hooke's law. So the force is equal to the spring constant times the displacement from the equilibrium position. Think if you were to compress the spring with a mass on it, then let go. It expand outwards, converting potential energy into kinetic energy because it moves as it expands outwards. But since the system is frictionless, the spring would overshoot its resting position, which would then cause the kinetic energy to be converted back to potential energy, and then it'll be converted back to kinetic energy when the restoring force brings it back to its resting position, where it'll then overshoot again because there's no friction. So this is how a spring will oscillate. For springs, the period is given by 2 pi times it by the square root of the mass divided by the spring constant. The frequency is still 1 divided by the period, or the inverse of the period. So in this case, the frequency for a spring system is 1 divided by 2 pi multiplied by the square root of the spring constant divided by the mass. Now let's look at an example. What is the period and frequency of a 30 centimeter long pendulum on Earth? Starting out, let's write down the variables we know. The length of the pendulum is 30 centimeters, which equals 0.3 meters, and the acceleration due to gravity on Earth is 9.81 meters a second squared. Now, let's recall the formulas for period and frequency for pendulums. The period for the pendulum's frequency is given by 2 pi times by the square root of the length divided by gravity, whereas the frequency is the inverse, so it's 1 over 2 pi multiplied by the square root of gravity divided by the length of the pendulum. So we can solve for either the period or the frequency first, and then just use the formula that the frequency is equal to the inverse of the period to find the other. Let's start by solving for the period first. Putting in the values we have into the formula, we get that the period is equal to 2 pi multiplied by the square root of 0.3 meters divided by 9.81 meters per second squared, which is equal to 1.099 seconds. Now, to find the frequency, let's just take the inverse of the period. So we get that the frequency is equal to 1 divided by 1.099 seconds. And this gives us the final answer, where we see the frequency is equal to 0.91 hertz, as 1 hertz is equal to 1 divided by a second. So that's how we get the unit hertz.